Hello students, today we are going to discuss the problems basing on what we completed in the previous class, the electrostatic topic. We completed the two topics, that is force, Coulomb's inverse square law force concept 1 and electric field concept and line concept, and some applications also we learned. Now we are going to discuss the different model problems and the previous year's questions we are going to discuss in this. So how many maximum problems we can do it in this video, we'll try to do our best to complete the problems, and we are going to cover the more number of problems models in this because electrostatic is a big topic. So don't try to miss the how to do the problems, so that it will be useful for the practice and for the preparation for the long terms or short terms or any higher level questions to solve it. It is useful too. So look at the first question in this. So they given, basing on the force concept here, they given two charges. One is Q1, second one is Q2. Two charges is given. These two charges are separated with a particular distance d is given, and what we are doing, we are placed one of the medium of the electric constant K. That means we taken the two charges Q1, Q2, and this Q1, Q2 is filled with the this Q1, Q2 is filled with the electric constant K metal. We are inserting between them. Now, what is the equivalent distance between the charges in air for the same electrostatic force? That means whenever I taken the two charges, there is electrostatic force of repulsion between these two, and this electrostatic force of repulsion I am taking as F medium, that is Fa. Now, if the same charges when you taken, that is Q1, Q2, so there will be the distance may be different. Initial distance you take it as R1 if you say, second distance I am taking as R2, the distance. So we have to keep the two charges in a particular separate distance in air. What is the medium here? Air is the medium. In this case, the force of repulsion between these two is equal to Fa. The condition is here, this is the point, we have to equivalent distance between the charges in air for the same electrostatic force. Same means equal. So I can say simply here, electrostatic force between the two charges in medium is equal to electrostatic force between the two charges in air. That's it. So you take the formula of this one. What is the formula? 1 by 4 pi epsilon naught m into charge is equal to Q1, Q2 by square of the distance between them. What is the distance? That is R1 square is equal to what is the force between the two charges in the air? That is 1 by 4 pi epsilon naught into, that is Q1, Q2 by R2 square is the distance between them. So here you need to understand what is same here. Here charges are same, the distance is not same, and here it is the permittivity of the medium, this is the permittivity of the free space. So I can write this in terms of like this, 1 by 4 pi. The permittivity of the medium I can write in terms of epsilon naught into K I can write. That is called relative permittivity. I can write that relative permittivity is also called as dielectric constant, because they given dielectric constant in the question into, that is Q1, Q2 by R1 square is equal to, simply I can write as 1 by 4 pi epsilon naught, that is Q1, Q2 by R2 square. So what I can cancel here, if you see this one, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, we can cancel Q1, Q2, Q1, Q2, we can cancel. The remaining is equal to what I can write, K R1 square is equal to simply R2 square. So what is the question they're asking? So what will be the equivalent distance between the two charges in air? That means what is the distance between the two charges in air? R2. They are asking to find the R2 value. So R2 square is equal to nothing but K into R1 square if you write. So simply I can write R2 is equal to, it becomes into root, that is root K into R1, it becomes R1, because R1 square root is equal to R1. So simply I can write as R2 is equal to R1 times of root K. We can write. This is the expression for R2. Now next question is related to net electric field concept. In this case, what they given is, they given one of the charges. These charges are located as you're looking in the diagram. So what is not diagram, sorry, in the question, what is given? A point charge 10 microcoulombs is at origin, that means coordinate system. At what location, that means at what distance on the x-axis should 40 microcoulomb charge has to be placed so that electric field is 0. At what distance? X equal to 2 centimeters. So I am taking the coordinate system here. Consider the coordinate system. so that we can understand clearly. So this is the coordinate system I chosen. Now in the coordinate system, first charge is taken at origin. This is the origin place. If we say at this origin, what is the charge we have? 10 microcoulombs we have. Now this is x-axis. On this x-axis, where we have to keep the another charge. What is the charge of that one? Another charge of 40 microcoulomb. This is the 40 microcoulomb. Another charge, that is 40 microcoulomb you have to place. At what distance? We don't know that. R is the distance. If we say this distance R only, they are asking to find. Now in this case, what they said, the electric field intensity is 0 at what distance? X equal to 2 centimeters. At a point, if the electric field intensity is 0, that point is called as null point or neutral point. So that neutral point is somewhere in between the two charges because both are positive, so that you have to know that. So that distance of the neutral point I am taking as x. This x value is given how much in the question, that is 2 centimeters is given. So now they are asking to calculate which formula, which value they are asking to calculate the distance between the two charges. At what distance you have to keep it? 40 microcoulomb from the 10 microcoulomb. So concept for the neutral point. The distance of the neutral point formula x equal to r by 1 plus under root of q2 by q1, plus or minus is the formula. Otherwise under root of q2 by q1 into, okay, q2 by q1 plus or minus 1 is the formula. Plus we have to use if they are like charges, minus we have to use if they are like charges. In this case, both the charges are like charges, so x equal to I can write as r by 1 plus under root of q2 by q1 I can use. Now they are asking which value r value. So r is equal to I can write as x into under root of, okay, sorry, x into what I can write 1 plus under root of q2 by q1. Now substitute all the values which you know that. What is x value? 2 centimeters. Keep it in that, so that you will get the answer in terms of centimeter. Otherwise 2 into 10 power minus 2 you can write 1 plus under root of what is q2 value? Second charge. Second charge is 40 microcoulomb. Okay, 40 into 10 power minus 6 by q1 first charge 10 microcoulomb, that is 10 into 10 power minus 6. To solve this one, what you are going to get? The answer 10 power minus 6 cancel, 0 0 get cancelled. Okay, so if you solve it, what the answer you are going to get? R is equal to nothing but 2 into 10 power minus 2 into 1 plus root 4 value is equal to 2. Root 4 value to 4, okay, 2 means 1 plus 2 how much? 3. 3 to the 6. 6 into 10 power minus 2. That is nothing but R equal to 6 centimeters is the answer for your question. So the answer for the question is 6 centimeter. That is first option according to the question. Now this question is given a point charge is 2 into 10 power minus 2 coulombs. One of the point charge is given, that charge value Q is equal to 2 into 10 power minus 2 coulombs is given, is moved from P to S in the uniform electric field of 30. They are given one of the electric field, that electric field value, okay, 30 Newton coulomb minus 1. In that we are moving that charge from P to S, P point to S point again. So directed along the positive x-axis, directed along positive x-axis. If the coordinates of the P and S are 1, 2, 0, 1 means along x-axis, 2 means along y-axis, Z means at origin. So in this case, we say this is 1 and this is 2. This point locates here. From this position, this point position we are calling as P position to S position. What is S? 0, 0, 0 means that is at origin. So we are moving the charge from where to where? From P to S. This is the way you are moving the charge. So P to S, what direction it is? We are moving the charge, the uniform electric field, okay, directed along the positive x-axis. That means the electric field which you are applying here, that electric field will be acting on this system of charges in this direction. This is the direction of the electric field. You are applying the electric field along x-axis. Now the coordinates of the P and S is given respectively. The work done by the electric field in this case, how much work is electric field is doing? What is the work done by this electric field to move the charge from P point to this S point? This work done they are asking to find from P to S. To calculate this one first, there are two positions given, that is P position, that is position of the P point is equal to, in terms of vector based we can write, that is nothing but I can write as 1, 2, 0. I can write as I plus 2j plus, okay, that is I plus 2j. There is no k here, k value anyway 0. This rp is equal to I plus 2j. Next, rs. S point is located at origin. Origin means what is the position of this one? 0. So in this case, change in position is equal to delta r is equal to, that is rp minus rs. P with respect to s is equal to, if you write this one, that is I plus 2j here. This is the change in position of the charge. Now, what is the work done? Work done is nothing but we can write as work is equal to force into displacement. We can write force into displacement. What is the displacement here? This is the delta R is the displacement here. So what is force here? Force equal to, according to electrostatics, you know that electric field is equal to force acting per unit charge is called as electric field. From this, force acting on the charge is equal to, we can write as EQ. So substitute this formula here. So F is equal to EQ into change in position of that one, that is I plus 2j. Now what is E value? Already given in the magnitude, so no need to, okay, much difficulty. And what is Q charge? That is also given, 2 into 10 power minus 2 coulombs into this I plus 2j is given in terms of vector form. So work is a scalar form, so this must be required vector form. So what is the magnitude of this RP? Okay, that mod delta RP, mod delta R, okay, P to S is equal to, we can write as under root of, okay, this is the, okay, case of 1 square plus 2 square unit, that is equal to how much? Under root of 1 plus 4 is equal to nothing but root 5 unit. So change in position in terms of magnitude is equal to root 5. That root 5 you can apply here, root 5. So if you calculate this one, how much you are going to get? That is 30 root 5. Sorry, 30 root 5, not 30. Here 2 is also is the 30 into 2. That is nothing but you are going to get 60. So that is 60 root 5. 60 root 5 into 10 power minus 2 joules. This is the work done in scalar form. Check the options, whatever the options which are given here. Now this value, if you calculate nearly according to the given option, work done is equal to this, we are going to get 120 into 10 power minus 3 you are going to get. So if you want to write in terms of millijoules, answer is given. So work done is equal to, I can write as 1200 into 10 power minus 3 I can write, that is nothing but called as 1200 millijoules. So here it is not 10 power minus 3, this is 10 power minus 2. So what is the answer here? 1200 millijoules. The answer, there is no negative here, so there are options of positive also is there, negative also is there. So in this case, change in position is equal to final minus initial, which is the final one, S is the final one, and okay, P is the initial one. That's why you have to take RS minus RP. If you take an RS minus RP, you are going to get here minus sign, because exactly if you taken, because here negative value also means delta RPS is equal to, so that means S to P. This is initial and this is final. So according to that one, final minus initial, nothing but RS minus RP. So that becomes minus of I plus 2j here. Minus of I plus 2j means all the way you will get the minus sign here. So because that change in position, we are going to get minus here. So answer also minus. So in the options, fourth option is correct option for this question. Now this question, one of the question related to the spring system oscillations and electrostatic combination question. These questions are type of questions are asked in the competitive examinations. First, what is given? A block of mass is M is given, and it is contains a negative charge is given, and placed on the frictionless horizontal table. There is no friction. If it is friction is added, that will be becomes a little bit more complicated problem. And connected to the wall through unstretched spring of spring constant K. This is connected to one of the spring of spring constant K. Now, if the horizontal electric field is applied, we are applying the horizontal electric field as you are looking in the diagram. So the spring and switched on. Then maximum compression of the spring. What happens here? Negative charge always moves in the direction of electric field. That's why this negative attracted by electric field. That's why the charge tries to move in the direction of the electric field. That's why what happens? Spring is going to be compresses. So here concept is this electric field is doing something on this charge. That due to that one, what happened? The spring is compressing. So they're asking the maximum compression of the spring is. That means first, who is compressing the spring? That is important. Electric field is compressing the spring. what it is doing, it is applying the force on the charge, so that what is happening, the block is moving, the charge is moving, okay, by displacing through a distance of x. That x is called as maximum compression. So in this case, the electric field is applying the force, by attracting force, and due to that force it is displacing. So I can say some work is taking place by the electric force, okay, electric field force. What is the work done? Work done is equal to nothing but we can write in terms of, okay, electrostatic force into displacement. Now this work making the spring to be compressed, so that means that will be stored in the form of energy in the spring as a spring energy. Clear? This is electrostatic work will be stored in the form of spring energy. What is spring energy? Whenever the spring is compressed through a certain distance, the energy stored in the spring is equal to half kx square. Electrostatic work is equal to F into x. So this total work done by electric field will be stored in the form of spring energy. So I can write here, okay, force due to electric field, force due to electric field into x is equal to half kx square, I can say, because that energy is completely transferred. How much it is transferred, that much compression will be there. So in this case, x is called compression. So x, 1x cancel. So they're asking to find which value, x value. So x equal to what you'll get, that is 2 times of electrostatic force by k you will get after cross multiplying this one and making this one by rearranging. What is E? Electrostatic force. In the case of what is the electrostatic force? Electrostatic force equal to E into Q by K. So the answer for the question is 2EQ by K. So second option if you see, 2EQ by K is the answer for this question. Next question, what is the largest charge metal? How much metal sphere we can take? Metal ball means sphere. How much bigger size of sphere we can take, so that radius is 1 mm of that one, so that it takes maximum amount of charge. So what is the largest charge, okay, on the metal ball of 1 mm radius? So that means I taken one of the sphere of radius 1 mm. So how much charge it can able to take, maximum how much it can take. So dielectric strength of the air is given. Dielectric strength means that is in terms of electric field strength is given. Dielectric strength, that value is equal to how much given, that electric field strength is equal to 3 into 10 power 6, that is volt per meter is given. Dielectric strength is also called as electric field concept is given, right? So to calculate this one, first electric field intensity due to a sphere, formula is, what is the formula? 1 by 4 pi epsilon naught, that is Q by R square is the formula. Here our requirement is Q, so Q is equal to what I can write, E into R square by 1 by 4 pi epsilon naught I. So what is E value? E value already very clearly given, that is electric field strength 3 into 10 power of 6. Check that units are all are in the same, units are different units. This is 3 into 10 power 6 into what is our radius? How much radius is given? 1 mm. 1 mm means 1 into 10 power minus 6 meters, that is whole square we can take, by 1 by 4 pi value 9 into 10 power 9 is the value of that. If they given not given, that you have to know that. So if you calculate this value, how much you are going to get? This we can write as 3 into 10 power 6 into 10 power minus 12 divided by 9 into 10 power 9. So you can calculate here, this is 3 times it will go, and 9 this is minus 3, that is plus 3, that is if it is went up it becomes minus. So in this case, what is the given value? That is 10 power 6, right? And denominator is 10 power 9, right? So if you calculate this one, so what you are going to get, this value, the charge on this one is equal to nothing but, so this is 3, how much you are going to get? 9. So 9 means that is 1 by 3 into 10 power minus 9 coulombs you are going to get. So Q is equal to, that is nothing but 1 by 3, 10 power minus 3 means nano coulombs. 1 nano is equal to 10 power minus 9. Now look at the option here, 3 nanocoulombs, 1 by 3 nanocoulombs, 2, 1 by 2. So what is the answer correct? 1 by 3 nanocoulombs is correct for this question. Now this question related to, okay, electric field in the between, okay, different regions of the sphere, concentric spheres concept. So in this case, a capital Q is given in the two spheres, that is inner radius, that means inner radius of the sphere, that is A, and outer radius of the sphere is B, that is called as nothing but what we call place at the conducting spherical shell of inner radius A and outer shell is B. The electric field due to the charge Q at the first region, second region, third region. What is the electric field intensity they are asking? First, you know the concept that whenever the charge is not there inside the region, then electric field always will be zero. So in the first region, if you see this one, there is a charge is present. Due to this charge, okay, inside this region, there is electric field will be present. Suppose this charge is not present, then there is no electric field. So electric field must be there inside this region. So E1 is not zero. So first option, okay, E1 is zero is first option wrong, and fourth option also not possible. So either B and C. Next, second region. If you come across the second region, it is called metallic. Okay, metal conductor. Metal conductor means always electric field intensity inside the metal conductor is always zero. So it is zero always. So E2 value where it is zero, it is also zero. First option will be wrong, and second it is also zero. It is also zero. Both are correct. So we can't decide. Go to the third region. Third region is outside region. So when you come across the outside region, this is the charge Q if you taken. There is induced charges are going to be developed here. That induced charge creates one more charges outside also. So due to this, what happens? There is electric field exists outside of this spherical ball of having inner radius and outer radius. So there is electric field outside also. So in the case of option B, so electric field intensity not zero means there is electric field intensity. Here electric field intensity zero means it is not correct. So which option correct? Electric field in the first region exists. Electric field in the second region, metallic conductor inside zero, and outside is present. So second option is correct. Now this question, one of the related to equilibrium condition of the question, you can see this equilibrium. So this is given the previous one of the G exam, what is G 1985. So here 2-point charges plus 9E plus E kept at a distance of A separation they given. Now what they given? A third charge. We are keeping one more charge between the two charges, between the two charges at a distance of x from plus 9e along the line joining of the above two charges they given. Now what is the x value they are asking to find? What is the x value? So that means here you can consider this is the line along which the charges are placed, we can say. So first place we taken, this is the place where we taken plus 9e. Another charge is kept at that is plus e, and we have keeping one more charge. Okay, so a third charge is placed at a distance of x from plus 9e along the line joining of the two charges for the third charge to be in equilibrium. That means we are keeping one more charge here. Okay, that charge value is not given, so that the system will be equilibrium, x value. So they're asking to find the what position you keep the third charge, so that the system will be equilibrium. Is they given the third charge value? You check it that one. In this case, each other a third charge is placed at a distance of x from plus 9e on the line joining of the. A third charge value is not given, so we have to check it that third charge is you take as q, and based on that one we'll try to solve it this one. So third charge to be equilibrium means what is the meaning of this point? Suppose I am imagining here I want to keep the charge. So whenever you are keeping the charge, what happens? This plus plus repels, plus plus repels. So the net force acting on this one must be equal to 0. That means in terms of electric field, I can say this is the region where the electric field intensity has to become 0. That is nothing but null point concept. So they are asking to find the position of the null point. The formula for position of null point by the two charge system of similar one is similar one is x equal to, that is r by 1 plus under root of q2 by q1 is the formula for this. So in this case, what is r? R is the distance between these two charges. That distance between these two charges in this question they given as a. You can look at this one, they given as a is the distance between these two charges. So I can write the formula as a by, that is 1 plus under root of q2 by q1. Now substitute the other values, you can find the x value in terms of a. X equal to a by 1 plus, what is q2? Q2 is called second charge. Now this becomes second charge, this becomes first charge, because always we are taking the distance of null point from the first charge. So that is e by 9e you will get. So e get cancelled. So we are going to get a by 1 plus 1 by 3 you get, because root 9 is equal to 3. So if you solve this one, 3 plus 1, that is 4 by 3. 4 by 3 means that is nothing but 3a by 4. So answer for the question is, what is the answer? X equal to 3a by 4. This distance where the charge if you are keeping that charge will be in equilibrium due to two charges. So 3a by 4. C option is correct. Now this question is one of the conceptual question. Already we discussed in the theory. You can check it that. What is given? They given two plates here having surface charge density. One is positive charge density. Second one also positive. Both are positive. Then electric field in the three regions they're asking. First region, second region, third region electric field they're asking. They give the options here. First, to understand here, you take the first region. In the first region, already we discussed that, okay, the positive charge density, electric field will be in this direction. Similarly, second charge density also positive one, so its electric field also at this point will be in the same direction. Both are in the same direction. So electric field in the first region is equal to, so electric field due to first and second, that is nothing but we can write as E1 plus E2 we can write. So simply I can write as sigma by epsilon naught plus sigma by epsilon naught. That is nothing but we are going to get 2 sigma by epsilon naught. 2 sigma by, sorry, sigma by even value is sigma by 2 epsilon naught. Sigma by 2 epsilon naught is a formula. So if you add it 2 times, 2 sigma by 2 epsilon naught you will get. So 2 get cancelled. In this case, you are going to get sigma by epsilon naught. But in the case of directions also given here, plus and minus, that's why you care. This is a negative x-axis. That's why this value you have to take as minus sigma by epsilon naught. So electric field in the first region must be minus sigma by epsilon naught. Which option is correct? You can check it. First is not there, second also not there, third one is also not there, fourth one is correct. Okay, D option is correct. Now you can go for the second region. Second region is a middle region where the electric field intensity due to this first, okay, charge this like this, and due to second charge plate this is like this. Both are opposite. Both are opposite means what? Net electric field in the second region is equal to E1 minus E2 we can write. Both are equal. If you say both are equal, that is sigma by, okay, 2 epsilon naught minus sigma by 2 epsilon naught, both are becomes equal to 0. So that is equal to electric field in the second region is equal to how much? 0 you are going to get. So 0 is correct. First one is minus, second one is 0. That n cap is indicates a vector, no, that's why we have to write in the form of magnitude. If you want to write in the form of magnitude, so E arrow is equal to nothing but I can write as n cap is the unit vector of that one. So in this case, second option there is no this vector. So third option, sorry, third region. What is third region? This is the third region. In this case, both positive plates creates electric field in the same direction. So here also that is E1 plus E2 only, but it is in the positive x direction. So this values you are going to get sigma by 2 epsilon naught plus sigma by 2 epsilon naught we are going to take, that is equal to 2 times of, we can write as sigma by 2 epsilon naught we can write. So in terms of electric field as a vector quantity I can write the third region, I can write this one as n cap. So 2 to get cancelled. So electric field in the third region, okay, is equal to what I can write, that is sigma by epsilon naught n cap. So third option also correct. That means third point also correct. So D is the correct answer for this question. Like this, we have to check the basic concepts which are given. So next, look at the question they given in the previous IIT 1988 question, conceptual based question, and little bit mathematical approach question. An electric line of force in the xy plane, that is two-dimensional plane. This is x-axis, y-axis in this plane. There is electric line of forces are given. That equation given x square plus y square equal to 1. This x square plus y square equal to 1 is called as, okay, circle equation. So there is a circular form electric line of forces acting is given. Now what is given here? A particle with the unit positive charge, that is a particle unit positive charge initially at rest at point x equal to 1, y equal to 0. That means I taken here at this point we taken a positive charge, okay, point charge, that is at a position of x equal to 1, y equal to 0. Then what is the condition in that plane? What happens? Not move at all. That means the charge will, okay, not move at all. Anyway, the electrostatic force applies the force on the charge, so the charge will anyway move. First condition. So first option not correct. Second one, will move along the straight line means, is it moving along only x-axis like this? No, because the electrostatic force is not a straight line, it is moving in a circular path. So second option not correct. Third one, will it move along the circular line of force? Yes, because the charge always repels and it always moves in the direction of the electric field. So the charge will be tries to move in the, okay, direction of the circular line of force. This is the correct option. and information is not sufficient to draw the any conclusion means. So they are not asking to calculate only conclusion, so we can able to do the conclusion using C option. Now look at the one of the important model, okay, problem. A vertical electric field of magnitude 4 into 10 power 4.9 into 10 power 5 Newton Coulomb is applied. So vertically we are applying, vertically means upward direction. So if you see this one, we are applying the electric field as are looking like this. The value of this electric field is given, E is equal to 4.9 into 10 power 5 Newton Coulomb minus 1 is applied. Just to prevent the water drop of mass 0.1 gram from falling. That means this is one of the water drop, you can say. The mass of this water drop is equal to how much? 0.1 grams is given, and the charge of that one is equal to how much water drop, and they did not given the value of the charge on this one they are asking. So the value of charge on the droplet will be, so there is a charge on the droplet, if you say that is Q, how much. So what is the concept here? Actually droplet will fall down, okay, it will fall down under the influence of gravity, yes or no, because it is having mass, the mass will be pulled by gravity, so there is a weight of the, okay, water droplet. This weight of the water droplet, due to that it is trying to fall down. Now this water droplet contains a charge Q, that's why what happens, it is going to be repelled by this electric field. Electric field repels the positive charge, so due to that it experiences the electrostatic force upward direction. So in this case, to balancing condition, okay, what is the question here? Preventing water drop to fall. Preventing means it should not fall. It should not fall means it has to be equilibrium. At equilibrium condition, the electrostatic force means the force by the electric field must be balances the, okay, must be balances which one? Weight of the droplet, that is mg. This is a concept here. Now what is the force applied by the electric field? Force applied by the electric field is equal to EQ. EQ is equal to mg. So they are asking what charge on the water droplet, that is equal to Q is equal to, we can write as mg by E, I can write. So what is m value? M value is equal to 0.1 grams means 10 power minus 3 kg into gravity value 10 by E, electric field. Okay, electric field value how much is given? That is 4.9. So here gravity value is given as 9.8 as to take. So you take the 9.8. So if you take a 9.8 by, so given electric field is 4.9 into 10 power 5 is the value is given. So 4.9 how many times in the 9.8? That is 2 times, it will cancel. So 10 power 5, if you make it upward, it becomes plus, that is Q is equal to, so it is already 10 power minus 4 and minus 5, that is minus 9, 2 into 10 power minus 9, 2 into 10 power minus 9 coulombs is the answer to your question. So which option is correct? The second option is correct, 2 into 10 power minus 9 coulombs is the charge on that water droplet. So that, okay, what happens due to weight, it is falling down, electric field, okay, applies the force on that to balance it to not to fall. Next one, they given a hollow spherical conductor sphere of radius 2 meters and carries a charge 500 microcoulomb. They're asking electric field strength on its surface, at its surface. So electric field intensity due to hollow spherical shell formula. What is the formula for electric field intensity on the surface of the any hollow spherical shell? E is equal to 1 by 4 pi epsilon naught, the charge of the sphere by radius of that one, that is square of the radius of that one. This is the formula we have to know. If you don't know the formula, you can't solve it. Okay, that's why it is required. So what is given here in the okay concept? Charge is given. Charge is how much is given? 500 microcoulomb is given. And next, radius of that sphere is given how much? That is equal to meters is given. First, before solving, you check that all are in the SI units or not. Now to solve this electric field intensity here, 1 by 4 pi epsilon naught I can write in terms of 9 into 10 power 9 for the calculation purpose. Q is equal to 500 microcoulomb, 500 into 10 power minus 6 by radius. How much? 2. 2 square means nothing but 4. We can write 4 here. How many times I can complete? This is 125. 4 that is nothing but, I think you will get 500. Okay, so we can write 125. 125 into 9. How much you are going to get? This 10 power 9 and 10 power 6, that is 10 power 3 you are going to get, and this is 9, that is 1125 into 10 power 3 you are going to get. So 1125 into 10 power 3 means, what way I can write it? okay, by keeping the 3 decimal points extra. There is no decimal points, we have a 10 power 3, so 1.125 into 10 power 6 I can write. So this is electrical intensity in terms of Newton per Coulomb. So which option is correct? If you see the options, so the second option is correct, that is 1.125 into 10 power 6 Newton per Coulomb is the answer for this question. Next question related to one of the linked with friction, because coefficient of friction based question linked with electrostatics. So that is the point you need to understand here. You have to club with the topic and you have to find the formula for it. They given two identical charges. How many charges? Two charges. So two identical means similar charges they taken. That is okay. Having mass is given. Mass of the charge is given 10. Okay, 10 grams, and the charge is given 2 into 10 power minus 7. So I'm taking here one charge here, second charge here, and both are separated by distance of L. I'm saying here on the table it is. So each charge value is given 2 into 10 power 6. Each mass is also given. Are placed. Now what they given? L is the distance between. L is the distance between such that they are in limited equilibrium. They are in equilibrium because they are repulse each other. Actually, due to repulsion, what happened? They are not in equilibrium. But okay, limited equilibrium means something is there which is making it equilibrium. What is that making? If the coefficient of friction between the particle and table is, that means if there is any friction acting between these charges and table, so that friction value is given as mu is equal to how much? 0.25. Coefficient of friction is given. Find the value of L. Using that concept, they are asking to find the L value. First, here concept is, here if you observe the two charges, both are positive, right? Similar charges means positive. Positive means this charge will repel this one in this direction. So this is the direction of the repulsion, right? Now, at the same time, when it is repulsing, what is happens? It is on the surface actually. It is on the surface. Whenever it is on the surface, the charge is when it is on the surface. In this case, what happens? There is a frictional force is going to act on the, okay, between the surface in this direction. Charge is experiencing a repulsing force, that is electrostatic force is okay acting on the charge is this side, right side. At the same time, the charge is on the surface. Between the surface, there is an opposing force is going to act, that is called as frictional force. Now both are forces only, so both are equal. At that condition, it is in equilibrium, limited equilibrium. This side equilibrium means what I can write here, at the condition of equilibrium, the frictional force is balanced by electrostatic force. This is the concept of this. Now what is frictional force here? Frictional force is nothing but, according to basic formula, mu into mg is the formula. Electrostatic force between these two charges is equal to, what is the formula? 1 by 4 pi epsilon naught. Two charges similar, that means you can write as q square, okay, by square of the distance between them. What is the distance between them? L is the distance between them, so I can write as L square. So what question they are asking in the question? They are asking to find the, okay, so what is the question they are asking? L is the between them, and find the value of L. Find the value of L. What is L value? L is equal to how much they are asking to find. So to find the L value, so here we have L value. So substitute all the values, and the last we can able to. Mu value is equal to 0.25. I can write as 25 by 100 into mass of the each charge is given 10 grams in the question. 10 into 10 power minus 3 I can write. Gravity they ask to take 10 is equal to 1 by 4 pi epsilon naught value, that is 9 into 10 power 9 I can take as, okay, that, okay, 1 by 4 pi epsilon naught value. What is Q charge? There are two charges are separated, that is 2 into 10 power minus 7 coulomb. So 2 into 10 power minus 7 whole square by L square. So from this first, as okay, how much we can cancel? We can cancel it. That is nothing but here 2 zeros we can cancel here. We can cancel it. This is nothing but we got 25 into 10 power minus 3 is equal to, this is 9 and this is 2 square. 2 square means 4. 9 4 is 36 into 10 power 9. This is 10 power minus 14 because minus 7 whole square is 14. Okay, minus 14 plus 9, that is equal to nothing but 10 power minus 5 you will get. So 36 by 10 power minus 5 into L square you get. So from this, what I can write, L square is equal to, L square is equal to 36 into 10 power minus 5 by 25 into 10 power minus 3 I can write. So here also we can cancel. This is becomes 10 power minus 2. It becomes, that is equal to 36 into 10 power minus 2 by 25 I can write. So L square value. What is L value? Under root value. Under root of 36 into 10 power minus 2 by 25. So root 36 is 6. 10 power minus 2 root value is 10 power minus 1 by root 25 value 5. So 6 by 5 into 10 power minus 1. So what is 6 by 5 value? 6 by 5 value is equal to, that is 1.2 unit. 5 ones are, and there's a 5. Okay. And 1.2 into 10 power minus 1. That is nothing but, if you add one more, this is becomes 0.12 meters is the answer. So length between these two is equal to how much? 0.12 meters. 0.12 meters means in terms of centimeters, answer is given. This L value is equal to, in terms of centimeters, 0.12 into, okay, that is 100. If you multiply, that is equal to 12 centimeters. Okay, so if you look at the option, first option is correct for this question. Now, this is the question. Already we done one model of problem here. One more. This is given in the previous IIT 1989 question. So most of the books you can find this question. So point charge Q moves from a point P to S. This is the point P. This is the point S. A point charge is moving as you're looking in the direction. So at different points. In the electric field E, pointing parallel, okay, co-parallel to the positive direction of the x-axis, means there is electric field, you can see it is along x-axis direction. Now the positions of the point PQRS is given in terms of a comma b comma 0 to a comma 0 comma, like that they given one position, q position, r position, s position is given. Now they are asking to find work done by the field in the above process is given by work done. So what is the work done by moving the charge from P to Q, Q to R, R to S? So in this case, work done here, what is the work done we are doing? Electric field is doing the work to move the charge. So what way the electric field is does the work on the charge? The electric field applies a force on the charge. So work done is equal to force due to electric field into displacing. Where it is displacing? Initially it is starting from P point, finally it is displacing to reaching to, okay, S. Displaces means shortest path. So this is the shortest path, we can say it is a final displacement. So I can write that is change in position, displacement from P to S. So we need to find the, okay, answer for this one. So work done is equal to, what is force? E, okay, that is nothing but EQ. Q is called as charge, E is nothing but electric field. In terms of, okay, position is given in terms of a comma b, like that, x and y coordinates. So electric field is along x-axis. I can write in terms of vector quantity as EI cap. This is along x-axis dot, and what is change in position of the this charge? The change in position of the charge is equal to, we can write in terms of vector as final position, which is P is initial and S is final. So final position vector minus initial position vector RT. This is the value we need to calculate now. So to calculate this one, I am taking the concept W is equal to charge Q into EI, okay, cap dot. Now what is RS minus RP? What is RS? RS is the position of the S point. What is the position of the S point? S is this. This is the last position of the S point. Sorry, this is the last position of the S point. 0, 0, 0. That means we can write as, okay, 0 I cap. Okay, that is plus 0 j cap plus 0 k cap minus, because we have a minus, position of the P point. Where is the P point? This is the P point. The P point positions are given a comma b comma 0. That means we can write in terms of, that is minus a I cap minus, because plus is there but it becomes minus, minus b j cap plus 0 k cap. Now solve this one. So this, if you solve it, Q into E I cap dot, remaining this is anyway 0 all, and remaining only we left here is minus a I cap minus b j cap. So take the minus common, minus you taken common, minus Q into E. Okay, if you multiply this E I, okay, with the each term, that you are going to get, what you are going to get, that is E into I dot I. That is first term you are going to get as, okay, I dot I is equal to 1 and I dot j is equal to 0. So we have a first term, second term will value anyway become 0, that is minus Q into E into, so A you are going to get, because I dot I is equal to 1. I dot I. second term anyway. If you want to write, you can write it, no issue in that. That is minus q into e into, okay, that is b into, we can write as I dot j. So this value anyway becomes 0. So work done is equal to what I can write, minus, okay, q into e into a, you are going to get. So work done is equal to minus eqa is the answer to the question. So if you observe the options, if any options are given, no, no options. So this is the work done in this process from where to where, from P to R. These important questions in the previous IIT they given. And this is also one of the important concept question related to surface tension topic and electrostatics topic combination. So they given 64 conducting drops. So we have 1, 2, so on. You can see the diagram. These are the number of drops. The number of drops equal to 64. And each of radius 0.02. Each one having radius is 0.02. That is in meters. That is also important. And each carries a charge of 5 microcoulomb. Each one carries a charge of Q is equal to how much? That is, we are taking as 5 microcoulomb. Each one. Now what we are doing, we are combined to form a bigger drop. So when you combine all the drops, it becomes a single drop. The single drop you can see here diagram is a single drop. Now what they're asking here, when it is made as a single drop of certain radius r, the ratio of surface density of the bigger drop to the small drop. The surface charge density here, this 16 4 drops, okay, conducting drops, each one having radius r. So these are drops, okay. Drops means which type of charge density is volume charge density. So in this case, the charge density of this one is bigger drop is I'm writing as B, smaller drop density I'm writing as S. So they're asking to find the ratio of surface charge density of the bigger drop to the smaller drop they're asking. So first, what is, okay, charge density? Charge density is nothing but, in the case of this one, you know that charge occupied per unit volume of that. So volume of the bigger drop. Charge on the bigger drop by volume of the bigger drop. Now what is the surface density of the smaller drop? Charge on the smaller drop, okay, by volume of the smaller drop. Here anyway, each contains charge Q. So all when it is combined, so all the charges will be combined as a single charge Q. Q is equal to 64 times the total charge of this, each charge of that one, that is total charge. So in the case of this one, it is the all the charges individually if we taken or separately if we taken, the total charge will be, okay, combination of 64 charges will be there on each one. Now calculate the charge on the bigger drop. The charge on the bigger drop is equal to how much? 64 times a small charge. 64 into each charge is 5 microcoulomb. That is, we can write this. We can calculate the later, the calculation. Yes. Next, what is the charge on the smaller drop? The charge on the smaller drop is only one drop they're asking, that is nothing but 5 microcoulomb. Keep it like that. Volume of the bigger drop. The volume of the bigger drop is equal to combination of all the n number of small drops volume, that is n times of, okay, volume of the small drops. So in this case, the radius of the small drop is given, so I can write, so volume of this one is equal to n is 64 drops into volume of each drop is equal to 4 by 3 pi. I can write as small r cube. So volume of the big drop is equal to nothing but, we can write in terms of as, okay, 64 into, that is 4 by 3 pi into smaller value, that is 0.02 whole cube, we can write volume of the big drop. Now what is the volume of the small drop? Volume of the small drop is equal directly 1 drop, 4 by 3 pi into r cube, that is 0.02 whole cube. Now substitute this value, density of the big drop to the density of the small drop is equal to, we can write as a relation, that is charge of the B by charge of the small drop into volume of the small drop by volume of the big drop. So if you substitute the values in this, what is QB by QS? QB by QS if you taken, in this case 5 get cancelled, otherwise you will write 4, okay, for 64 into 5 into 10 power minus 6 by, and a small drop 5 into 10 power minus 6 is the charge ratio. Now what is the volume ratio? Volume of the small drop, that is nothing but 4 by 3 pi into 0.02 whole cube by big drop volume is how much, that is 64 into, that is 4 by 3, 5 into 0.02 volt. So we can do it in a short way, just for understanding we are going, okay, in a deep way, otherwise we can go directly here. So 5 into 10 power 6, 5 into 10 power minus 6 get cancelled, 4 by 3 pi, 4 by 3 pi get cancelled, and 0 point this is also we can cancel it. So what is the ratio you are going to get? That is, you are going to get 64, 64. 1 is to 1 ratio you are getting here. So is it correct or not? We'll check it that. The ratio of this one is rho B by rho S is equal to 1 is to 1. So answer of this one is equal to 1 is to 1. That is correct only. Okay, but here the options are given wrong. So you can modify this one, 1 is to 1. First option is correct. But if you want to get in the form of 1 is to 4, 4 is to 1 like that, that means it should not be a drop. Okay, it should not be a drop. It must be a bubble. Because that problem also we have bubble. If we take in a bubble, it is having surface area, not having volume. So here it is having volume, it is also volume. Volume means the complete droplet contains the charges. So volume charge density is there, but these options given based on surface charge density based options are given. So our concept of, okay, according to this drop concept, the answer is both are having same ratio of charge density. Now if you look at this question, they given, okay, one of these square, okay, frame, on that we kept three charges of the three corners. They're asking to find the electric field intensity at D point. Look at this question, the magnitude of electric field E at the corner of the D square. So they're asking to find, but the charges are not same. A corner contains Q by 2, B Q, and C point Q by 2. So what is the electric field intensity at D point? So to find that one, I taken the diagram here to understand clearly. So now, so electric field intensity. So electric field intensity is a vector quantity. What direction you have to take the electric field intensity? In the direction of the repulsion, right? So here, imagine a test charge at D point. If you imagine a test charge Q naught here, now this Q naught will be repelled by a charge. A will repulse this Q naught. What direction? This is the direction of the repulsion. This is the direction of the repulsion. It will be by the A charge. That I am writing as force by the A. FA I am writing. Similarly, B. B charge is having magnitude Q. It is also repulse. The repulsion always takes place along the line joining between these two. So from here, it is going to repulse each other. That means this Q repel this Q naught in this direction, as we are looking like this. This is the way it is the repulsion takes place. This force of repulsion by the second charge I am writing as Fp. And third one, C. This is the magnitude Q by 2. It is also repulse the Q naught in the direction of the line joining between these two. So I am writing the force of repulsion by this one also in this direction like this. This is I am writing as Fc. So if you observe this one, Q by 2, Q by 2, this A and C charges are same. So that means charges are same from the Q naught. Okay, and the distance also same from the Q naught, right? So that means A charge, C charge, both are at the same distance. Separation, okay, separation of the both the charges the same distance. So force on the Q naught by the A charge and C charge is same. That means this is A, this force, this is C, this force, both are same. I am writing as F and F, both are equal. So when both are equal, so here the two forces which are perpendicular to each other, 90 degrees separation. So according to using which one, parallelogram law of vector addition, I can find the direction of that one. That direction of that one we can write as a direction like this. The resultant of these two will be in this direction. So this resultant I am writing as FR1. What I am writing? FR1. What is FR1? FR1 is the resultant of FA and FC. So according to our concept, FA and FC are both are same, equal to F. So FR1, according to parallelogram law of vector addition, both are separated by a certain angle, that is 90 degrees. If you apply that, so I can write the formula FA square plus FC square plus 2 FA FC cos theta we can write. So in this case, what is FA? FA nothing but F, that is F square plus F square plus 2 f square cos 90 degrees. Cos 90 is equal to how much? 0. Sin 91, cos 90 is 0. This total value will become equal to 0. So I can write fr1 is equal to nothing but f square plus f square, that is root 2 f square you will get, that is nothing but root 2 f I can write, because square and root get cancelled. So resultant of A and C will get root 2f. Now FB, B point charge having force F. What is the force of the B charge? FB is equal to, concept is formula 1 by 4 pi epsilon naught if you taken Q by, charge is Q, Q naught by R square. What is the distance here? This is the distance. If you see this one, okay, here they given any side of length, they did not given any side of length. Okay, square of side is A is given. So you take the A is the side of this one. Now this is also, if you take another A is the side of this one, then automatically this diagonal in between, this becomes root 2. So the distance between the Q and Q naught will become from the B point is root 2a. So I can write FB is equal to 1 by 4 pi epsilon naught Q naught by square of the distance between B and Q naught, B and D. So what is the distance? That is root 2a whole square, because as for the formula, square of the distance. Now if you solve it, what you are going to get? This is 1 by 4 pi epsilon naught Q naught by a square, I take it common, and root 2, that is nothing but 1 by 2 you get, because root 2 whole square is 2, a square is a. So here FB value in terms of F, what is F here? This F is the force between Q by 2 and Q naught. F is the force between Q by 2 and Q naught. So that force I can write in terms of as FA is equal to FC is equal to, I can write as 1 by 4 pi epsilon naught. One charge is Q by 2. Okay, that 2 I am writing in denominator. Second charge is Q naught by R square. What is the distance? A square. So it is also looking like in the same form of above, 1 by 4 pi epsilon naught, that is Q naught by A square if you taken, remaining is 1 by 2. So what if you observe that FA value, FB value, FC value, 3 are looking like same. So but the FA and FC both are perpendicular to each other, so resultant is FR1. This FR1 value is equal to root 2F. Now FB value also equal to, same value you are going to get as FA and FB. So I can write here FA value is equal to FB value is equal to FC. 3 are same values. Same values means I can take it as F. So net force equal to what I can write now. So net force on the charge Q is equal to F net is equal to 3 are same forces means FR1 plus FB I can write. Look at this one. This is FR1 and this is FB. Both are acting in the same direction. So directly these two plus gives the net force. So what is FR1? FR1 nothing but both are got root 2F. What is FB? Just we got this is FB. That FB is equal to FA value. So I can write here in terms of FR1 is equal to, I can write as 2F, and FB value is equal to FB value I can write is equal to FA value, that is nothing but F you can write. Yes sir. What is F value? 1 by 4 pi naught Q naught by A square. So if you take an F common, what you are going to get? Root 2 plus 1. Check the options in this so that we can able to go to the next solution for this one. So here also there is a error in the question. I think they may be not having Q by 2, they may have a all Q. If all the charges are, if you taken as a Q, in that cases we can write the equation for this one is equal to almost you get is equal to, okay, this is only the answer, but in the given options which are not correlated to this one, that means there is maybe error in the given values of this one. So note down this one, but our derivation of this one is equal to F into root 2 plus 1 is correct according to the given question. So here the question in the given, they are asking to find the electric field intensity. No need to worry about it, because you know that electric field, okay, force electric field test statement is equal to force acting per unit test charge. The test charge is imagined, so electric field is proportional to force only. So the whatever the derivation we got, that is corresponding to electric field only. Now this question we thought it is wrong. Now it is given as per the solution only. Okay, after referring, I can find. This is what is the final answer we got? F net. That is nothing but I am writing corresponding E net is equal to nothing but okay electric field intensity due to this one into root 2 plus 1 we got, right? So what is electric field intensity? That is corresponding force. The corresponding force of any one of the charge is equal to this. So what I can write, that is nothing but 1 by 4 pi epsilon naught. In the case of electric field intensity, we have only one charge, that is Q by A square. Okay, by 2 also is there, by 2, that means 1 by 2, that is nothing but I am taking as here by 2 into root 2 plus 1. So this 2 make it inside, this becomes electric field intensity. Net electric field intensity is equal to nothing but Q by 4 pi epsilon naught into A square. If you make the root inside, root 2 by 2, nothing but 1 by root 2 plus 1 by 2. So options are given in this form. You can check this one. Electric field density at that point is equal to, at the D point is equal to what is given. So Q by 4 pi epsilon naught A square into 1 by root 2. Okay, plus is there. So plus means which option correct? First option is correct. So the question is correct only, it is not a wrong. Okay, charges are given, everything is correct. So only modification of the answer is required, that according to the given options.